Hi, welcome to the Sugar Math Lab and Differential Equation Problem Solving section. So today we are going to work on a second order differential equation. And for this ones here, if you take a look, they say find the solution of the following initial value problems. Is y double prime minus y prime tangent t plus 2y equal to 0, and with the initial condition y0 equal to 1, y prime 0 equal to 3. Do you remember in our previous video, so when we solve in the second order of the differential equations, and in this problem, they did not give us the first solution, and let's try to find the second solution. So just like before, we need to do a guess to see what could be the first solution. And if you watch the other videos, we said that the solution we try to use to guess is like x to the r sine t, sine x, cosine x, those values, right? So in here, and we have a tangent t here. It's a trig function. So probably I will choose the y, our first solution will be a sine function. Okay, so this is my guess here. Okay, so now I will say my y1 will be equal to the sine t. Okay, so now after this is my guess, right? So I want to guess then after if I find one solution, then I will be able to use the reduction method or use the Abel formula and try to get my second solutions here. So y1 is the sine t. So let's see if that work or not. All right. So then the first derivative sine will be the cosine t. And then y1, the second derivative will be the negative sine t. Okay, so now let's substitute to the above differential equation. So y prime double prime is negative sine t minus cosine t times the tangent t, right? Times the tangent t. Tangent t is sine t over cosine t. Then plus 2y plus 2 times the sine t. Wow, very good. We see the cosine and the cosine cancel out here. That's good. So I have a negative sine t minus sine t plus 2 sine t. So this will be negative 2 sine t plus 2 sine t equal to 0. That is great, right? So because it's equal to 0, so I know it's satisfied this differential equation. So I know my y1, the sine t, is a good guess. Okay, so now we can continue try to find our second solution. Okay, so I start the guess here. So that's good. So now the differential equation is y double prime minus y prime tangent t and plus 2y equal to 0. So I know this will be, so let me rewrite this so I can circle better. So this one's here, I will say is y prime minus tangent t, then y prime here, all right? So then this things here, the negative tangent t, I can treat this is my PTs here. Okay, so now here, so I would say my PT is equal to the negative tangent t. Okay, so now I'm going to use the Abel formula. Okay, so the Abel formulas would be the negative PT dt, the integration. So this will just be the integrator tangent t. Okay, so because it's a negative, then negative, so it's positive tangent t. So, okay, so I have a positive tangent t dt here. I need to integrate that. And I know the tangent t is equal to the sine t over cosine t dt. So then I can do what? I can do u sub, right? Okay, so u sub. So I can u sub here. I will say u equal to the cosine t. So du is equal to the negative sine t dt. Right, so here, okay, so this ones here will become negative, right? So negative u du. So what I have here is a negative natural log u here. Okay, so it's natural log u. And then my u is a cosine t, so it's a negative natural log cosine t. Okay, and then this will be the natural log 1 over cosine t. Okay, or I can say that it's a natural log secant t. Okay, all right, so natural log the secant t and plus c1. Okay, now I'm going to put into the e negative based on the Abel's formula pt dt. Okay, now here the pt dt, so now this will be e to the natural log secant t and plus c1. So what this will be equal to? It's going to be equal to the secant t times e the c1. I can call that this is just another constant, right? So I can say this is the secant t times another constant c1 here. Okay, so now so maybe I should write the Abel's formulas here just in case someone not familiar with that. So y2 going to be equal to the y1 times here, this is the y1t, the square, and then here is an e to the negative pt dt. Okay, and then this is dt. Okay, so we did the numerator part as the second t. Okay, so now I'm substitute here. I will have okay, so now here we'll have this ones here. I'm working on the inside integration. So it will just be the secant t c1 times the secant t. Okay, then the bottom is the y1 square. y1 is the sine, right? So I have the sine square t dt here. Okay, so this ones here, I can take the c1 out. And this one here is a secant t sine square t. Okay, so this is the dt here. All right, so this integration is a little tricky, but now I can use, okay, so I'm working on is how to get this integration done. Okay, so what I want to do, I can do integrate by part. Integrated by parts here. Okay, so now I will set the u is equal to secant t. All right, then du is going to be equal to the secant t tangent, right? So secant, take the derivative, secant tangent. Then the remaining is dt over sine square t. I call this dv. Then I integrated the v will just be integrated the dt sine square t. So sine 1 over sine square t is a cosecant square t dt. Okay, so the cosecant square, the integration will be the negative cotangent t, right? So it's going to be negative cotangent t. Okay, now I will do the UV. So this one's here. Okay, so this will be C1 times UV. So it's second t times negative cotangent t. UV minus VDU, so it's minus minus is plus, so it's plus VDU, so it's a cotangent T times the secant T times the tangent T dt. Okay, so now let's take a look here. All right, so here secant T, I need to use some trig identities here. Second is 1 over cosine t. Negative cotangent is a cosine t over sine t. Wow, cancel, cancel. So I know this term gives me negative 1 sine t. Okay, so this one's here, cotangent and the tangent, this is cancels, right? So now I'm only going to be plus integration of the secant t dt. So, okay, so now I'm going to use a separate page, separate space. Okay, so for integrate the secant t dt, remember the tricks we use is secant t. So I'm times the secant t plus the tangent t. Then this is the secant t plus the tangent t dt, right? So this will be the secant t plus tangent t. Then this is the secant square t plus secant t tangent t dt. Now you can use the u sub. You can say this is the u's, right? So u is equal to the secant t plus tangent t. Right, and then the du will just be the secant square, secant t, tangent t, plus secant square t dt. So I know all this will become du. So the whole thing is here going to be du over u. So it's a natural log u. Okay, so now I know this integration is here. So will become to the natural log secant t plus tangent t plus another c2 here. Okay, so now, okay, so here let's rewrite it a little bit nicer so we can see. Okay, so this will be C1 times negative 1 sine t plus ln secant t plus tangent t plus some c2 here. Okay, now my final, remember the Abel's formula? In order to get y2, you times y1. Right? So now final y2 is equal to the y1. y1 is what? y1, what do we guess? We guess it's sine t, right? All right, so here, let's see here. So this will be C1 times sine t, and the whole distance, negative 1 sine t plus ln secant t plus tangent t plus c2. See. All right, now let's do it. So I times this one, formula in, formula in, formula in. Okay, so this will be the C1. So this is -1 plus, all right, so this will be the -1 plus sine t ln second t plus tangent t, all right, then plus like the C1, like the sine t, so I can have another C constants here, right, the sine t. Right, so because when you plug that one in, so this one will be some other constants. You can say it's just C1, C2, 1. Okay, so this will just be when you times the constants here. So this will be sine the C2, C1. So be this. So we call this another constants C2 here. Okay, all right. So now here. Okay, so this is my y2. Okay, so now my initial condition, let me write it here. My initial condition is y0 equal to 1, y prime 0 equal to 3 here. Okay, so now y0, so y0 equal to 1, so 1 is equal to c1. So y0, you put every zeros there, so this will be -1 plus, because sine sine t here, this is zeros, right? Then this one's here, second t, this is 0 plus 1, so naturally it's 0. Okay, so here this is plus 0, just very tedious. Then c2, sine t is 0, c2 times 0. So I get the c1 is equal to the -1. All right, let's highlight this, so later we will need to use it. So it's easy to find. Okay, now I need to do is y2. All right, so I need to find the derivatives. Okay, so the derivative for y2 prime, this is going to be c1. All right, so -1 become constant. So product rule, so this is a cosine t times ln second t plus tangent t, right? Then plus sine t. So the ln, the derivative of this one will just be what? The derivative of this one will just be the second t, right? Because we just integrated to become here. Okay, so now plus c2, so c2 cosine t. Okay, now I plug in the first derivative, so the 3 is equal to, okay, now let's see here, cosine t 0, this is 1, and this is the 1 plus 0, so all this natural is 0. Then this is 0, and this is 1. So all the C1 constant from 0. So not bad. So I got a C2 equal to 3. Good. All right, so here this is C2 equal to 3. So finally, I got my C1, I got my C2. So what is my final solution? My second solution will just be C1 is -1. So it's -1 plus sine t ln second t plus tangent t, right? Then C2 is 3, so it's a plus 3 sine t. Wow. Okay, finally. Okay, so the whole thing is very tedious. It's the integration part here. So that's it. That is my solution here. So all right, so this is our another example. Want to solve the differential equation without giving you the first solution. So that's why you need to, try to make a very educate the guests to see what could be my first one. Like we said, the typical one we use is the extra the x power sine x or cosine x. So in here, I choose a cosine x, and then I want to make sure, the cosine x satisfy this differential equation. All right, I hope this help, nice to talk to you. And if you have any questions, feel free to send me, put the comments, send me an email, or send me, put a comments later. All right, so that's it. Have a good day, and let's talk to you next time. Let's work on the another problems. Okay, bye bye. Have a good day. All right, bye.